What is poppin'? What is poppin' is we're going to try to figure out why update animation takes 50% of the CPU when we are playing back tests. That's a lot. It's really a lot. It seems like almost all of that is in eval, which is weird. But yeah. So I wonder, like, there's lots of things that could be happening. Maybe we're calling it too many times. Like, we call it per entity type. Like, why do we call it on rock? You don't like have animating rocks yet. Oh, because it does. Okay, this update animation. This update animation actually does other things. Doesn't really do anything for rocks, though. But that doesn't even matter. So, although maybe it does. We'll find out. It's doing something. It's doing something messed up. Okay, so this is happening. In simulate, and we call simulate potentially multiple times per frame, but not really that many times per frame. I don't know. Let's start counting things. Okay, that's the number of simulate. We're going to say how many frames num a player eval calls is S32. So we're going to go into animation. And then we're going to go into main loop. Do one frame. Okay, and then when we advance level, because that's something that happens a lot. I'm actually kind of hungry. We might have to make this a relatively short stream, and then I get dinner and then do another stream. Or we do yet more Uber Eats. Okay. So we're just looking at what's going on here. I don't know. That didn't print anything, but let's see. Where is it? Oh, frames 1400, sims 1500, evals 21. I mean, that's not crazy, I guess. 28, 28, 34. I don't know why we would. Let's actually go, let's start on heroes 1, 1. So that we know what level. Actually, you know what? Let's make this easier to find. Easier to find. All right, we're just going to hang out on this level for a minute. As far as I know, this guy is the only thing that has an animation player going. That water in the background and the particles, that's other stuff. It's not using this system, so, all right. Frames 891, sims 920, evals 920. Okay. So most frames were short enough that they were one sim step. Some of them were more. And the number of evals is equal to the number of sims, as I would expect. Same there. Let's go to like promised one. This has a lot of I mean, what's animated here? The doors actually are probably, maybe they're not calling eval. Maybe I should reset this so we could see per level. Sims 34, evals 38. I mean, none of this is ridiculous. I'm not seeing anything banana nutso. $53, $58, okay. Not crazy. Not crazy at all. Okay, so what if I run and start doing Benny test? Is it worse during the Benny test? Quite possible. So I would expect our number of sims to be more than the number of frames. Look at that. Way more evals than sims. Look at that. Why so many? It's like a ratio of 5 to 1 right now. So it's really something that's only happening during test playback. It's 7 to 1. Like, it's increasing over time, which is also nutty. Although we're having more levels with more characters. Having more than one sim per frame is not that surprising. But having that many frickin' evals is... nutty. I guess. I mean, on some levels... Okay, here's what I'm going to do. I'm going to reset it every frame. So we can tell per level, like if the expense is going up or down. Oops. All right, redoing it. Okay. I mean, air skating has like 3 characters. The Arcadia levels have like 4 characters, but there's way more evals. Why are there so many evals? Like frickin' arrangement. Look at that. Okay. Okay. There's like 11 characters. Maybe that's why it was just so much. I mean, maybe that's fine then. Yeah. Actually, 11 characters. 24. Maybe it's not actually wrong. Maybe like Bardcliff too? Does that have 8 characters? I'd believe it. Yeah. Okay, well, actually this number, even though it's quite high sometimes, that's just because sometimes there's a lot of dudes. It doesn't look wrong to me. Although Arcadia is weird. Because these levels have 4 characters. Whoops. Okay. Like, there's like twice as many evals as I feel like there should be. But maybe the gates are doing animation player eval? They probably are. There's probably 4 for the gates. Yeah, I mean, I think just the levels with lots of monsters are causing it to be called many times. Which means it just really is that slow right now. And the question is why? Why didn't it start life back as a hash table? Because we didn't even know what entities IDs were when we started making the game. They're different than they were in the last game. And because we didn't have to. Look, we got this far without doing that hash table. So why should I have done it before? Like, it's a weird question. Like, why didn't you already do the work that you didn't have to do until now? Well, because I didn't have to do it until now. All right. The work that we do have to do now, I mean, we don't totally have to. Okay, my current question is the following. I'm gonna hope we get debug info in release build. And I want to know if this is also 10% of the profile in release build, or more maybe, or 50%. Or is there something about debug code generation that is causing it to be especially slow? I could imagine either of those things being true. So I want to close this solution. And I don't think we ever did one for the non-debug. So open, can I just say open project solution? Is it done? Yeah. Okay. So do we have debug info? Let's just break in the middle. Let's see what happens. We do. Great. Okay. So we're gonna run a Benny test with performance profiler on. Oh. Let's actually start from here, because I don't know if that works. So we're just gonna let this run for a little bit. And then I want to know, is it also 50% here? Or what, what is it here? It didn't seem like more work from the start to use the hash table because we didn't know what anything was. Like, look, when you're first building a system, you want it to be simple. So for example, one of the things that often goes wrong if you're building a game engine is like, oh, I registered an entity, but it didn't show up somewhere that I wanted it to. Or, oh, I unregistered an entity, but it stayed around in something that I didn't want it to, and somebody else tried to use it and crashed. Well, guess what? If you have a spare hash table recording that kind of thing, then that's exactly the kind of problem that you're going to have. And so to minimize that kind of problem, you don't do those things until you need them. It's really pretty simple to understand. Like, I think you're just not thinking about it from the standpoint of sitting down to build a system yourself. Isn't there an argument for cognitive space being used when it could be free until you actually need to have the thing? Oh yeah, of course. There's lots of arguments in that direction. Yeah. You organize your entities in a 2D array for O of 1 lookup. That's O of 1 lookup by position. What if you want to look up something else? What if you want to iterate over all of the characters? Or what if you want to look up entity ID 273? It's different. I don't think that what I'm saying is specific to game development. I think it's specific to being a productive programmer that is building large things, as opposed to, like, if someone is, a lot of programmers are like, they're building a small piece of a thing, and it's the piece that somebody else told them to do, and they told them more or less exactly what to build. And in that kind of a case, then you would put that hash table there because someone probably told you to do that, right? That's not, like, if you're building something from the start and you don't even know what it is, it's a different kind of programming. Let's see where we're at. Okay. It's not 50%, but it's 35%, which is still a lot. And it says eval is all of it, but I'm going to assume that that's because everything else inside there got inlined. Guys, chill out on the horns out there, man. Yeah. Well, this is a lot. So this is the eval that we're looking at, and you know it does a fair chunk of stuff, but it's not that bad. But you know, it iterates over things, doing a fair chunk of matrix and mathematics. So I think what we actually want to do now, since we've got this information that yes, this is taking a lot of time, I actually want to go back to the debug build where things are not so inlined and I can see more procedures and just see relative to each other how important they are, which again may be distorted because it's debug, whoops, may be distorted because it's debug build, but yeah, you know, it is what it is. Because I want to see all the little subparts there. Any reason I'm using Video Studio instead of RAD telemetry? Because this is not in C++, and so we don't have bindings for telemetry right now, and I haven't investigated how easy or hard they would be. If I thought they would be easy, I would just do them, but I haven't even looked because there's a lot of work to do. Or just collecting data. How long do we let it go? I don't know. Another minute. That's a lot of data, I guess. It does seem, I mean, even for something that gets called 10 times per frame, which it is sometimes, that means it takes 3% of the CPU per time, which is a lot. I'm just saying. I'm just saying. Okay. 2 minutes. Stop collection. Wait, why is this? Did we not run the? Why is it all STB Vorbis? Oh, we didn't get the right debug build with the right. Dope. That was a waste of 2 minutes. What does run code analysis do? I wonder if that'll tell me anything useful. All right, we'll give it another 2 minutes. What do I think of video games as a means to learn complex concepts or systems? I recently started playing an RBMK reactor simulation because I watched the new Chernobyl series. I think that's a good way, a good thing to do with games, sure. We're at 1 minute. Maybe I should stop it at 1 minute, but we're giving it 2 minutes because, you know, I'm not sure where the levels with the lots of characters are sitting in the sequence. Like maybe the frickin' monsters just have a lot of bones. I don't even know. I like don't even know, man. All right, we're at 2 minutes. 2 minutes. Yeehaw. Bam. Bam. All right, now we have symbols. Wow, it's even more. Well, eval is 45% again. It's interesting that, like, I mean, there's a bunch of optimization that I guess needs to happen because simulate, not including the animations, is 20%, which I guess I buy that because it's really sloppy. But yeah, like send message is, oh my God, dude. That's a thing to look at. There's so many things to look at. Okay, wait. String to float. I guess that's parsing the levels. Blah. Get Xform state, 10%. Is that where we literally just do a decomp? Who calls this? Calling functions eval, get Xform state. This is an animation channel. Well, wait, I don't see. Let's go look at that. So disable lerps is not going to be on because that's just a debugging thing. So we do this lerp of these Xform states. And that's 8% of the entire program, I think. I think that's what that 8% means. Okay. We lerp translations. We call slurp that's definitely asking for it. And then scale is lerp. I mean, yeah, we probably shouldn't call slurp there. Let's try that. We have long since fixed the things that led us to be conservative in there. Do we have an nlerp or do we not? Let's get symbols. I guess we have nlerp. Let's see if there's any visual problems. Ugh. Wait, is that how that's supposed to be? I don't know. The animator's been adding more like classical animation stretchy things, and I never know. Like, this looks very weird to me, but maybe that's just because I slowed it down. It's a revised animation. Okay. Like, sometimes you stare at something too close and you're like, that looks weird. I bet the difference is not visible to the eye. I mean, I think it looks the same. Does this look different to anyone? Some people say it looks the same. Some people say it looks different. Well, here's the thing. If it looks different, it could only really be different between animation samples. And these animations are at like at least 15 FPS. I doubt that it really looks different. Rotation seems faster? No, that's not true. I mean, it might just be that I'm playing it back at a different speed. Okay, let's just do this for now. And then we're going to see what it does to the speed of get xform state, which used to be 11%. So we're going to do 2 minutes. I don't know why I picked 2 minutes. It's a little too long. But we're going to do it again to be consistent. And we're going to see. You think it looks different when you change tile when it's still finishing the animation, it blends to the next direction? Nope, I don't think so. Because that code doesn't apply to that case. That's the problem is, you know, we're setting up a situation where it's extremely subjective and weird. Like what I should do is have there be like a flag on the character that says which one to use and put two of the same guy next to each other and have them playing the same animation and make sure it doesn't look different. Switch between them while paused. Yeah, that could work too. And 2 minutes. Okay. Eval is 44% instead of 45%. That's not that good of an improvement. But it doesn't even put, like, I don't know why how it picks what to put here. But like that, actually, let's go back. Wait, is this the right one? Yeah, 44%. Get Xform state. It's still 10%, bro. That didn't help at all. I mean, this lerp, I guess this used to be 8.5%. Now it's like 7.5%. Okay, this is really bothering me. Why is it that slow? Sure doesn't look like we do very much here. I mean, do we just call it 1 trillion times? I assume that this lerp is the Xform state lerp. We could like name it. Oh, I can click on it. Wait, that's the wrong one. Go back. This is the, yeah. So this one. Okay. Well, it takes like 9%. It calls this for half its time. The matrix 3 lerp. Okay, well, this can definitely be expanded to not use the for loop. And to not call another lerp. This is going to be a weird thing because it's like, hey, we would like to have enough control over the compiler to make sure this generates the right code. So first of all, force inlines like this are not totally implemented right now. So we can't guarantee that this inlines. In fact, it looks like it's not right now. Dude, hook these things up. Make the arrow go back. All right. So that's one thing. If we had this working, which we don't because it's a low priority, and if we could say like unroll on a loop like this, then you would be guaranteed that the code that it would generate would be close to good. Maybe still not, because like, how do you make sure the array references get eliminated? I don't know. But it's at least very likely. But we like can't guarantee either of those things right now. And again, especially in debug builds, it's like, well, what's going on, right? So we definitely could expand that out and just see what happens to the time. It's like 5% of the time of the entire game, which is huge. And, by the way, almost always unnecessary. Anyway, because here's the thing, is these XForm states they are built to handle this very generic case of all animations having arbitrary 3x3 scale shear on them. And as far as I know, none of our animations actually do that. As far as I know, we just need to lerp a vector 3 or something. So an alternative way to optimize this would be to make the animation system realize like, oh yeah, we don't actually use this. I'm inclined to do both though. So for the matrix 3 lerp, I'm just gonna, okay, I also actually want to go eat and then come back and stream some more. So what we're gonna do is we're gonna expand out the matrix 3 lerp, but we're gonna leave the old one. And we're gonna say, you know what? We should be able to build enough compiler features that we feel confident that the old one is just as fast, even in debug build. So I'm going to write that comment. It's going to be a mission statement for the future of the universe. Okay. Mission statement. Okay. We would like to be able to write the following thing. Yeah. See this note here? For scale shear, it's fine. But for a general transformation, you don't want to lerp your matrix 3 anyway. But these aren't like object rotations. Okay. To be able to write the following thing instead of the expanded out code below. And have full confidence that the compiler generates something efficient for it even in debug builds. Like, so like, I don't know, unroll for whatever, blah, right? You should just be able to force unroll a loop if it's over a known number of things. That's a very easy unroll, right? If it's over an unknown number of things, you could say unroll paren something, right? Okay. We're just going to say yay, 9 times. 1, 2, 3. Actually, let's do this. So we only have to change one digit. 2, 3. 2, 1, 2, 2, 2, 3. 2, 1, 2, 2, 2, 3. 2, 1, 2, 2, 2, 3. 2, 1, 2, 2, 2, 3. Oh wait, I said T of. That should be T times. I'm getting a little mathy. 3, 1, 3, 2, 3, 3. 3, 1. 3, 1, 3, 2, 3, 3. 3, 1, 3, 2, 3, 3. 3, 1, 3, 2, 3, 3. And then T paren becomes T times paren. Does that look right? All right, so I'm going to do it again. 2 minutes. Actually, let's just make sure we can walk around and stuff doesn't explode. Okay, I'm walking around. All right. Start. Two minutes. You start your matrices at 1, 1. Yeah, well, the 1, 1 is the math notation, right? And the 0, 0 is the programming notation. So whatever. There's no right answer. Whichever one you pick, someone's going to make a mistake. Any questions about what's going on besides the ones that are currently being asked? Just be like Perl and have configurable indexing. No. 2 minutes. Boop. 2 minutes. Eval down to 42%. We're making progress. I mean, who knows if we impacted release build at all? Oh, actually, let's go back and get Xform state. It's still 8%, dude. LERP is still 4%. This didn't. Okay, this one's at 1%. I thought this one was at 4% before. Oh, this one was at 10% before, right? So this used to be like almost 5%. Now it's 1. That's still too much, frankly. But again, it's debug builds, so who knows? Okay, we did. Our number is going down. Eval is going down. I mean, it's 3% down now, which is fine. That's almost a 10% improvement in eval, which is not nothing. But it doesn't look like there's going to be like a single silver bullet. It looks like we have to just visit all these things and make them go fast. Oh, well, the single silver bullet is probably the other thing, which is that we don't actually need these giant ass matrices. So I think that's what we're going to do is when we load the animation, we can detect whether there's non-zero scale shear. And if there is non-zero scale shear, then we flag it on the, I guess we flag it on the, like per bone. So all this stuff, this get Xform state that's taking up like 8 or 9% right now. Is that basically all in the LERP or what? Get Xform state. It's not all in the LERP. It's half in the LERP or more than half, but external code. What does that mean? This is just a lot in this tiny function. It's really weird because I guess max index, like if there's just a lot of bones, you know, this iteration is like 100 or 200. But I should actually know how many bones are in these things. It's probably over 200 at this point for some of these guys. There's definitely some stuff I can do. So like we're iterating over here, we're grabbing some values that the compiler may not really know are constant, like anim.supplement sample index. Sample index is fixed here. So let's just do that. Let's just do that and see what we get out of that. I mean, of course, it's debug build, so the compiler isn't trying to lift things like that. Let's say sup0 only dereference if safe. Okay. So this is also just makes the code more. This isn't true anymore. God, this used to be hella slow then. So now we're just interpolating. So yeah. All right. So let's call this sup0, and this is sup1. And we're casting fraction down to float every time. Like literally every time. So let's do this. We're going to call it fraction 64 for the 64-bit. And then these are going to be there, right? That is not a particularly cheap operation sometimes. Okay, so fraction 64. All right. Let's make sample index like an S32. I don't think that really matters. I don't know. That might annoy me. Yeah. Okay, let's take out that for now because num samples is like 64 bits. So we have to take care of that number mismatch. Oh, wait. What? Oh, right. Okay. So we're going to see if that helped get X form state. In the old build, get X form state was 8.26%. And we're going to see what it is now. Is that a conditional branch? Yes, it is a conditional branch, but it's an easily predicted branch. In fact, oh wait, you mean this one or this one? Both of these are easily predicted. This one is almost always false. This one is almost always true. So I wouldn't expect them to have very much impact on performance. I kind of feel like we want all this to be S32 that's int right now. Oh, wait, what? Did we die? Did I mess it up real bad? What is int by default? It's signed 64-bit. Okay, we're not running the profiler. I just want to know. Exception. Okay, this is weird. Like this shouldn't evaluate the array at that index. So this shouldn't crash anything. So we need to look at that because that is a compiler bug. I think we can use pointer math for now. But you know, this is supposed to be the address of this element. You know what I mean? It's not supposed to actually do anything. So yeah, we may be generating extra code for these expressions, which would then indicate let's hope that works. No, we wanted to do, we're just going to be optimistic and assume it's not going to barf this time. Two minutes. Can you inspect the assembly? We could, but in a debug build, I mean, I'd rather just look at it when I want to solve the problem. Inspect the assembly. Like, I'm working on something else right now, you know what I mean? So I don't want to like rat hole on this other thing. And if I was going to work on that problem, I would rather do it like in our bytecode system, because it in principle, if that bug is what I think it is, then we should be generating the wrong bytecode in the first place, or generating extra bytecode, right? And that is very easy for us to see and resolve. So maybe we'll do that tonight a little bit. Advice on not instinctively going on Hacker News during every 2-minute break. Realize that Hacker News is mostly useless and people talking about things that they don't actually know very much about, and don't know that they don't know very much about. So they're exhibiting Dunning-Kruger syndrome most of the time, and Dunning-Kruger is contagious, and you don't want to catch germs, so stay away. All right. Eval down to 41. I mean, that's not that much lower, but okay, wait. Where were we? We were get X form state. Still 8%, dude. I mean, it was like 8.5 before, 8.1. So that didn't help that much either. I wonder if we're like dividing by something bad. Like, how can this be that slow? Aside from we just call it a lot. Like, it really doesn't look to me. I mean, okay, array bounds checks are present in the debug build. How many of those would there be? 1, 2, 3, 4 per loop iteration. I mean, that doesn't seem like that much. So what we sort of need here is a better profiler. We need something like vTune or whatever Intel is giving out these days that'll tell you like where in this procedure body is taking the time. And those aren't always completely accurate, but they tell you. Because I feel like if we could narrow it down to knowing which part is slow, then that would be good. It might just be that we're calling this a frickin' bazillion times. That's quite possible. But it's so weird because it's like, as expensive as the lerp. The rest of this body. Like the lerp is here, that's the expensive one. And then the rest of this loop is just like, get some values. Oh, this is constant. We can factor this out. But like there's not a lot here. So if that's like almost as expensive as that big lerp math situation, then I'm not sure why. Not sure why. Okay, we're factoring this out. Wait, what? Why is this in this loop? This doesn't make any sense. I mean, it's not going to save that much time by taking it out of the loop, but this doesn't, like we're doing this for every node, which is basically every bone, right, in the thing. Why is this inside this loop? Bro, it doesn't make any sense. Because the turning control is, it's just a property of the root bone. Right? So like theta offset 0 and theta offset 1, these are both constant, right? Because sup 0 and sup 1 are constant. And then these, okay. I mean, this, we have to be careful not to dereference, right? So right, so there, else, there. And then we can collapse this. Just make it less code, right? You want your big loop to be less code. And then, I mean, we can even just swap this, right? Swap this around. Let's do one thing at a time. Let's make sure we didn't break it. Oh, node.stay. Oh, right. Okay, we'll keep this. Let's hope we didn't break that. Oh. Oh, right. That's not a pointer. Haha, it's by value. It's by value. Okay. So it looks like we're still animating. Why did we fail to load one of our boulders? I don't like that. Oh, wait, no, never mind. That's just a dark spot. That's why is that a dark spot? That's weird. All right. Great. Great. Dude, I can do these levels in my sleep. Okay. Let's mark for no check-in. Oh, let's take out our frame sims evals before we forget about those. We established that these are fine. Okay, so now we want to factor this loop around. All right. So here, so even though I said this is a predictable branch, everything here is constant because sample index is just chosen outside. So I could do the following thing. Right? Else and then, assuming that works, we can fold that into that previous if that we just had, right? And then this is better for many reasons because now you could much more clearly see how to SIMD it and stuff, right? Like if there's if statements in the middle of the loop, you're like, how am I gonna SIMD that? But, you know, these are just loops with some math in them now. So, yeah, much better, much better. And in fact, for this, we can go there. Does that make sense to people? Or should we attempt to fix more nil values or attempt to index at nil value? Okay, so it's still working. So I think let's see if we impacted the performance at all. I'm not sure that we did yet. Actually, no, let's not yet. While we're still correct, apparently correct. Let us make these things S32. So num samples But why are we using the animation? That's dumb. I guess. Maybe not. Like, should I really allow more than 4 gigabytes of animation number of samples? Is that really a thing? I don't think that's really a thing. Just making sure when we read it. Yeah, it's probably fine. Okay, so we're going to make this S32. Wait. So we get sample index and then the fraction. Like, why are we, if num samples is equal to or less than 1, why would we even do this computation, right? I mean, I'm wondering if there's some div mod kind of a way to do this faster. But also, it's not worth worrying about. Like this denominator. Do we really need 64 bits in that denominator? I feel like no. But whatever. This is weird. We should be computing both of these. We should be computing both sample index and fraction 64 with essentially the same computation, but they are kind of different, which is maybe why I'm nervous and using float 64 below when 32 should do. Dude, it's July, man. It's July. Okay. So all this fraction stuff and then that. But sample index now is signed 32. And num samples, so yeah, I don't know. I don't know if any of that matters. But like, you can totally see how this would be a SIMD just thing. I mean, you'd have to expand the lerp and all that, but whatever. Whatever, we're just talking right now. We're just talking. Okay, let's make sure it's still correct-ish looking. Okay. And let's do a profile. Then I'm going to go get some food. I don't know if we actually sped it up by that much in debug build. We could do a release build profile actually as well, just to see. If there's a difference there. Does 32 versus 64-bit make a difference on 64-bit CPUs? Well, some things don't, but some stuff might, and I'm not sure. So like, we converted that value to a 64-bit float at one point. And I feel like 32-bit into 64-bit float may be faster than 64-bit into 64-bit float. Maybe it's not. Maybe it's not. It just didn't sit well with me that it was 64 bits. We would like whatever. If somebody wants to do some research on what the good Intel instruction level profiler is now, let me know. And we can download that later today on the next stream and try and use it to see exactly who is taking how much time, or maybe not exactly, but with more confidence than we are currently doing. This is, I mean, this is better than Visual Studio Profilers used to be. But, I mean, this is like, you know, this is 1999 technology right here. Okay. Eval 41, it was at 45 or 46. So we've sped eval up by 10%, and eval was 50% of the game. So that's good. It's non-negligible. I was hoping, though, that we would just see something super dumb and be like, aha, that was super dumb. Let's fix it. But so far, we're not seeing that. It's okay, though, because, yeah, we're going to do some things. Okay, so get X, still 8%, dude. Yeah, so we sped it up just a little bit, but not by a lot. So like I said, you know, so that if statement probably didn't cost us much, like I was saying, because we didn't get much out of eliminating it, at least in debug build. We'll see in release build. But it is worth the future streamlining of these things. Yeah. Okay, yeah, let's do release build. We're doing okay. This is just what optimization is like. Optimization does not really happen that quickly. Although earlier today we were spoiled because earlier today we had dumb bugs and I fixed them and the game got way faster. Sometimes that's what optimization is like, but when your program is not super dumb in the first place, then it's more like a long series of small gains. And that's what we're doing right now, is small gains. And we have a good case, actually. On the one hand, it's like, wow, dude, it's whack that animation is taking up half your frame time. I guess it is, but then our scenes don't have that much else besides animation, so maybe it's not that surprising. Not that much that would use the CPU. The GPU is doing a lot per pixel right now. But also that's a good case, because if something takes half your frame time, then that means by optimizing that thing, you could make your game potentially twice as fast. I mean, probably not, because that would involve making it infinitely faster. But, you know, that's very good. Whereas if it's just like everything is kind of slow, then you just sort of have to optimize everything to make it fast, and that's a lot harder to deal with. So even though it's like, oh my God, why is it half the frame or a third of the frame in release build? It's like, okay, that's actually good in some sense. Programming something big without auto. I don't use autocomplete. I don't know where you're from. I mean, I seem to get a lot of things done, so what does that say for autocomplete? Autocomplete just doesn't work well. It doesn't work well enough to bother with. Or I've never seen an autocomplete implementation that worked well enough to bother with. I mean, maybe if you type really slow, you can win with autocomplete. But the lose is that you've turned, so if you just know what you're typing, it's a non-interactive loop. You just blast out the typing or whatever, right? If suddenly you have to interact with this thing and like look at the window and pick the right one or whatever, that just slows everything down, man. Autocomplete helps in object-oriented programming. I don't agree. I don't agree. I mean, people use it. It's fine if you like it. I just don't agree. Okay, so again, I think eval was 34. So I think, again, we sped it up. Maybe it was 33. I threw away the old reports, unfortunately. We can go back and look at the VOD. It did get faster. Or was it update animation? I don't know now. We got to go back and look at the VOD. You should actually, if you're being serious about optimization, you should keep a record of the exact numbers, but you should also run a more exact test. Like I'm sort of stopping it after about 2 minutes every time, but that's like not really exactly testing exactly the same things. But the thing is, we want to get this whole thing so much faster that like we don't really care that much about like 1 or 2% right now. We're trying to get like 80%. And that's not happening yet, but it may happen with the thing that we do later. Maybe. Yeah, so it's around a third of the frame. It is what it is. It is what it is. Oh, let's go back to get X form state, because that was the thing that we kept looking at. I mean, it's 9% in release build, which is like actually more than it was in debug build, which means it is being slowed down less by debug build than other parts of the code, relatively speaking. So, I mean, this is still like 10% of the entire game is in this function, right? Am I reading this correctly? Yeah. Number of samples. 10% of the entire game is in this number of lines of code. I mean, all this like I mean, if num samples is less than or equal to 1, I mean, I think we prohibit it from being 0, and if it's 1, I think we just set something and then return, like, I don't know. Maybe not. Maybe we just fall through. It's not worth adding the complexity. Okay, I'm a little scared about this compiler bug, actually, because here's the thing is, you know, it was crashing when we did this, which means that maybe we're generating the code for this expression evaluation in addition to taking the address. Somehow we're doing both because we're getting the right value because our code works, right? Okay. That would also mean, if that is happening, that would also mean that down here, maybe that's happening here. Maybe that's not that bad, but it would be like, I guess the states are dynamically allocated, so it couldn't be like a giant memcopy, but it could be a significant memcopy slowing us down. So that's a thing to look at. But in general, I think the biggest optimization for now is not to do the crazy scale shear shenanigans that we're doing. Like, okay, so we're doing all this math. We're doing the 3x3 matrix lerp and like 4x4 multiplies out there, and most of the coefficients are 0. That's just where we're at. So I think we're going to detect that, because also detecting that, you know, when we give out the engine to people, they won't be paying for that feature if they don't use it as well. Am I going to use another profiler this stream? Well, this stream is going to be over and I'm going to get dinner and then come back and then we'll do another stream. If somebody knows what's the good profiler that I should use. Yeah, is the thing we do later the non-zero shear optimization? Yes. Yes. So I'm going to write that down. Optimization. gprof. Not. I don't like Intel just keeps changing Intel sampling profiler. Let's just VTune. Do they still? I thought it wasn't VTune anymore. I mean, maybe we'll try VTune and maybe it'll be better than. I thought they gave up on VTune and they had like GPT and then iPeak. Is that stuff still exist? Storage testing. I guess that was a branding initiative. Okay, whatever. Choose and download. Parallel Studio. System Studio. Only VTune. Private support. Support renewals. Let's just try the free one. I definitely have paid for VTune in the past, but it was like a long time ago. I am an adult, 18 years or older. Please select a product. How about the one for Windows? 2019 Update 4. They are actively updating this. All right, so we're going to try that as well when we, at the start of the next stream. However, I presume that we're going to be doing the scale shear optimization. Now all new with banner ads in it. Can you ask an off-topic question? If it's quick, because we're ending the stream for now. What is the off-topic question? Never used gprof. Why is it bad? It's not that bad. It's just 1980s technology. So, you know, it's technology from before many people in chat were born. Have I played Undertale? I have played Undertale, yes. I can't stand the skeletons. I didn't think, like, here's the thing. When I was in high school or like in college, I did all the standard nerd humor of the time, which at that time was basically quoting Monty Python and the Holy Grail and laughing about it or whatever, right? And like, if I play Undertale and these skeletons are trying to be funny, I feel like they would have been funny if I was 15 or 18, but they're like not funny now. And I just don't like them. And the game keeps stopping the gameplay for the unfunny skeletons. And yeah, I didn't like that. If someone wants to mod Undertale to not have the skeletons, maybe I'll play it. Again, I mean, I played it before, so you like the skeletons. Well, I guess maybe to each their own, right? Some people like skeletons, some people don't. I like the David S. Pumpkin skeletons. Was Undertale, did that come after David Pumpkins? Did he copy the skeletons from David Pumpkins, or was that an independent invention? Is the skeleton hiding inside you right now? I feel like Undertale was before David Pumpkins. Yeah. Maybe Saturday Night Live copied the skeletons from Undertale. You got your bike stolen. Well, welcome to San Francisco. All right, thanks everybody for coming by. We will start the stream back up in a little while after I get nourishment. Do I plan on getting married or something eventually? Well, not if I don't find a good person to get married to. So it kind of depends on that. I wouldn't mind doing that, but not going to get married to a random person, because that is really not good. All right. See you.